12 free lessons, you'll stop asking how agents work and start building one that actually does real tasks. You've seen clever chatbots, but agents are different. They sense, plan, call tools, and act. This video walks Microsoft's free 12-lesson course step by step so you can build agents yourself. I'll show which lessons matter first, which patterns stop failures, and exactly where to run code. By the end, you'll have a clear first prototype in mind, and a tiny plan to actually ship it. Ready to open the repo and get dirty with code? Quick map. Microsoft's course lives on GitHub with runnable samples and multi-language demos. You can try models for free via GitHub Models or plug into Azure AI Foundry for production features. The repo includes code, short videos, and step templates, so you can move from notebook prototype to managed deployment without guessing. I'll point to the exact folders and sample runs you should open first. But first, why agents are worth building in the first place. Agents matter when tasks are multi-step, evolving, and hooked to external systems. Picture a travel assistant that finds flights, checks hotels, calls booking APIs, and updates a calendar. A simple prompt can't reliably chain those steps. Agents structure memory, tool use, and retries so workflows don't break mid-flight. If you want reliability and action, agents win. Next, we'll define the core agent types and why each pattern matters for your product. Lesson 1 teaches agent types: reflex agents for quick responses, goal-based planners for multi-step objectives, learning agents that adapt, and hierarchical systems that split work. You'll see concrete examples and a travel booking demo that chains API calls, comparisons, and reservations. The key skill is choosing the right type for the problem. Otherwise, you'll overcomplicate or underdeliver. After this, you'll be able to pick a pattern and sketch the agent's responsibilities, and then pick a framework to prototype it. Lesson 2 compares frameworks: AutoGen, Semantic Kernel, and Azure AI Agent Service. AutoGen excels at multi-agent dialogues and rapid prototyping. Semantic Kernel gets planning, memory, and skill connectors for notebook work. Azure AI Agent Service offers managed scaling, governance, and observability for production. I'll recommend a path: prototype locally with AutoGen or Semantic Kernel, then migrate to Azure when you need monitoring and control. Next up, the design patterns that stop agents from becoming fragile. Lesson 3 is human-centered design patterns. Start with the user's job to be done, not model plumbing. Give the agent a clear role, boundaries, and success criteria. Use transparent summaries so humans trust results. Treat agents as collaborators that scale capacity, not black boxes. These patterns reduce surprises and make debugging possible. I'll show a short prompt template that sets role, constraints, and success metrics so the agent behaves predictably. And then we'll build the first tool integration. Lesson 4 covers tool use, the superpower. Instead of hallucinating answers, the agent calls APIs and functions with strict input-output contracts. Start with one safe tool, like a knowledge-based search. Add routing logic, sandboxing, timeouts, and retries. I'll walk through a simple function call pattern you can drop into a notebook, including JSON schemas for inputs and outputs. Once the agent can reliably call one tool, you'll see how to compose more tools without exploding complexity. Lesson 5 moves to agentic RAG, retrieval that plans and checks itself. Instead of one-shot retrieval, the agent iterates. Draft a query, fetch documents, evaluate results, refine the query, repeat. This maker-checker loop improves correctness and adds citations. It's the difference between guessing and researching. I'll describe an iterative flow where the agent queries a vector store, summarizes findings, and then runs a verification pass. That pattern keeps outputs grounded and defensible. But trust still needs design. Lesson 6 tackles trust, security, privacy, and risk controls. Build a system message framework, apply least privilege tool access, mask sensitive data, and guard against prompt injection. Most failures are design, not model problems. Use sandboxed execution, explicit tool permissions, and monitored retries to avoid surprises. I'll give a simple checklist you can run before any demo or deploy. After that checklist, you'll see how planning and metacognition prevent the agent from wandering off. Coming up next. Lesson 7 is planning. Agents that plan break goals into steps, assign subtasks, and use structured outputs like JSON. Imagine asking an agent to summarize a 40-page report. It splits the document, summarizes sections, aggregates themes, flags risks with citations, and drafts an executive summary. Planning gives predictability and makes failures traceable. I'll show a plan schema you can copy into your code to orchestrate steps and recover cleanly when a tool fails. Next, multi-agent setups. Lesson 8 teaches multi-agent systems. Instead of one overworked agent, orchestrate specialists, a researcher, a planner, and an executor. Use an orchestrator to assign tasks, shared memory for state, and clear protocols for handoffs. AutoGen provides ready patterns for agent collaboration. Start with 2 agents, a maker and a checker, and you'll get immediate quality gains. I'll describe a simple orchestration strategy that improves throughput and correctness, and then we'll add self-checking behaviors. Lesson 9 introduces metacognition, agents that critique themselves. Teach agents to reflect, run critique loops, and stop when a confidence threshold is reached. Use maker-checker pairs. Give the checker a skeptical system prompt and enforce loop guards to avoid infinite deliberation. This dramatically cuts hallucinations and overconfidence. I'll give a short critique rubric you can drop into a second agent to audit outputs and flag if human review is required. Coming up, production observability. Lesson 11 covers agentic protocols, MCP, A2A, and NL Web. Protocols are adapters that reduce glue code and make agents plug and play. Model Context Protocol standardizes how tools and prompts connect. Agent-to-agent patterns let agents delegate securely. Natural Language Web helps agents interact with web content naturally. Using protocols means you can swap components without rewriting your stack. I'll sketch an MCP flow so you can see how a single adapter simplifies tool access. Then we'll finalize with context engineering. Lesson 12 is context engineering, the movie, not the snapshot. It's about staging the right info at the right time. Write concise task prompts, select relevant knowledge, compress long docs, isolate instructions from memory, and stage content across steps. Treat context as a budget. Every token must earn its place. I'll give a simple staging pattern. Seed roll, retrieve top K, compress, then supply step-specific memory. That discipline keeps agents focused and consistent. Now a quick mid-video recap. Mid-video recap. You now know the core agent types, 3 frameworks to try, and the 12 patterns that make agents reliable and safe. You've seen tool use, RAG, planning, multi-agent orchestration, metacognition, observability, protocols, and context engineering. If you're following along, open the course repo and bookmark code samples. Up next, I'll walk a practical learning path so you don't get overwhelmed and actually ship a small prototype first. Phase 1. Foundations. Start with Lesson 1, 3, and 4. Define the agent role, design principles, and a single tool integration. Prototype in a notebook or a simple script. Keep the scope tiny. 1 clear success metric and 1 tool. This phase gets you to a reproducible demo you can run in minutes. After you have that demo, you'll be ready to add reliability patterns in Phase 2. Coming up next with reasoning and checks. Phase 2. Reliability and reasoning. Focus on planning, agentic RAG, and metacognition. Add a retrieval loop, structure outputs, and attach a checker agent with a rubric. Instrument traces for each step so you can replay and diagnose. This phase turns a demo into a reliable tool for real users. After that, we'll scale with multi-agent and protocols in Phase 3, which lets you split work and run concurrent specialists. Phase 3, scale and collaboration. Add multi-agent patterns, agent-to-agent delegation, and shared memory. Use protocols so agents and tools interchange cleanly. Build a maker-checker pair, then add a planner and an executor if needed. Test parallel workflows to speed up batch tasks. These patterns let you attack cross-domain problems with purpose-built specialists. Next, we'll prepare for production. Trust, observability, and context engineering to keep the system sane at scale. Phase 4, production readiness. Implement security controls, least privilege tool access, data masking, and monitoring. Instrument end-to-end traces and key metrics. Latency, cost, and tool success rates. Build safety checks and escalation paths for human review. Finalize context engineering so prompts and memories are staged and compressed. I'll share a deployment checklist you can apply before any stakeholder demo, so you won't be surprised by basic operational questions. Practical prototype ideas start with a smart research assistant that mixes web search, vector retrieval, and citation checks. Or build a customer support triage agent that fetches account data and drafts ticket responses. A sales ops copilot can summarize calls and update CRMs. Each maps to specific lesson patterns and is doable within a week if you scope tightly. I'll outline the minimal toolset and schema needed to launch each prototype quickly, and then warn you about common traps, common pitfalls, vague agent roles, tool sprawl, noisy RAG, lack of observability, and overfitting to demos. Fix roles with crisp system prompts and measurable success criteria. Limit tools, add timeouts and validation, tighten retrieval, and instrument traces from day one. Test with messy, real data to avoid brittle demos. These fixes prevent most failures and save days of debugging. Next, I'll give practical tips to get hands-on with the course quickly. Hands-on tips: clone Microsoft/AI agents for beginners, open code samples, and run the simplest notebook. Use GitHub models to avoid cloud costs at first. If you need governance and observability, move to Azure AI Foundry. Pick one framework and go deep for a week before mixing frameworks. Instrument traces early and write JSON schemas for outputs. These steps shorten the path from curiosity to a prototype you can demo to colleagues. Finally, a short checklist before you build. Before you build, checklist. Define the agent's job and success metric. Pick one tool, choose a framework, write an initial system prompt and JSON schema, enable tracing, and set a safety review gate. Keep deployment small and iterate daily. Following this checklist reduces surprises and produces reliable demos you can expand. In the final scene, I'll recap the fastest path to a working agent and point to the most useful repo folders to open first. Final recap: start small, pick patterns that match the job, instrument everything, and enforce safety early. Use the course to learn by building. Prototype in AutoGen or semantic kernel. Validate with GitHub models, then migrate to Azure AI Foundry when you need governance and scale. The repo gives runnable examples, templates, and video explanations that map directly to production patterns. Now go clone the repo, run the first sample, and build your first agent, and I'll see what you create next. If this roadmap helped, like the video and subscribe for hands-on agent builds. Comment which prototype you'll build first, and I'll point you to the exact sample to run.